Dear students, next we are going to study some aspects about work, energy and power. We are already in our everyday life, any physical or mental activity may be regarded as work. And we are already encountered with the different forms of or different types of work that we have usually do in everyday life. For example, a teacher taking a class is doing work, or the students learning while sitting on the benches are also doing work. However, all such activities do not fall under the category of work. So in physics, the work is said to be done only when the applied force causes some displacement of a body in its direction. For example, if you walking, you are applying force on the ground. Okay, so but your displacement is in the horizontal direction and you are applying the force in the downward directions. Also, in that case, we cannot say the work is done. Also, when you push a wall, here also you are applying the force, but the wall doesn't move. Here also we say that the work is not done. So in physics, the work is said to be done only when the applied force causes some displacement of a body in its directions. That means the work done by a body depends on the force applied as well as the displacement of the body. In physics, we are going to define the work done. The work done is defined as the product of force and the displacement in the direction of the force. Okay. Suppose when you pushing suppose you are sitting in the table, you are sitting on a chair and on your table there is a book. So when you apply the force to push the book moves in the direction of the force. So we say the work is done. And how can we calculate the work done? The work done is calculated as the product of force and displacement in the direction of the force. Here the book moves in the direction of the force. Okay. Suppose if F is the applied force and S is the displacement, then the work done W is given by force into displacement in the direction of the force. So W is equal to F into S. Since it is a product of force and displacement, even though F and the force and displacement are the vector quantities, this product, the product of these two vectors is a scalar product, and the result of this scalar product is a scalar quantity. That means the work is a scalar quantity. Okay. Now what is the unit of work done? So from the equation you can see W is equal to force into displacement. So the unit of force into the unit of displacement, that is Newton meter. Here the 1 Newton meter is called the joule. Okay. So when we write the unit as a full name, we should write in these small letters. When we represent it by a single letter, then that letter should be in capital. Here it is capital J. Okay. So 1 joule is equal to 1 Newton meter. 1 Newton meter. That is 1 Newton into 1 meter. Okay. So what is 1 Newton? That is a force, unit of force, that is equal to the 1 kilogram meter per second square. We know the expression F is equal to MA. So kilogram meter per second square into 1 meter. So we have another expression for the 1 joule, that is equal to 1 joule is equal to 1 kilogram meter square per second square. Now we are going to see what are the different types of work. What are the different types of work. So in the left side, in the bottom left side, you can see this figure. Here the ball is freely falling down. Okay. So why we know? Because the earth is attracted the ball by the gravitational force of attraction. So there is the gravitational force is acting on the ball. Okay. Here we can concentrate on the direction. Okay. Here the ball is coming downward, and the gravitational force is also acting in the downward direction. That means both are in the same direction. So in that case, we say that the work done is positive. Okay. The work done on an object is said to be positive. Positive work when force and displacement are in the same direction. Okay. So you can also explain what is the negative work done. Yes, that is when the force and displacement are in the opposite direction. That is when you throw a ball in the upward direction. Here the ball is moving in the upward directions, and the gravitational force is acting in the downward direction. Okay, in that case, the force and displacement are in the opposite directions. So the work done is negative. Okay. There is another type of work is the zero work. When we say the work done by a force is zero, here when the force and displacement are perpendicular to each other, okay, or when either force or displacement is zero. Let us see what are the three conditions. So when the force and displacement are perpendicular to each other, so you can look into the third picture on the right side. Here there is a potter. He is carrying weight on the top of his head. So he is applying the force in the upward direction. He is applying the force in the upward direction, but the luggage, the weight he is carrying, has a motion in the horizontal direction. Okay. So the force in the upward direction and the displacement of the luggage taking place in the horizontal directions. That means both these two directions are perpendicular to each other. So in that case, we say the work done is zero, or there is a zero work done. Also, and when either force or displacement is zero, okay, that obviously we have the expression work done is equal to force into displacement. If F is equal to 0 or displacement is equal to 0, then the work done will be 0. Okay. Now what is the energy? The energy means it is the capacity of a body to do work. It is the capacity of a body to do work. Okay. All living beings perform certain basic activities in order to survive. For performing these activities, we need energy, which comes from the food which they consume. Okay. Here, the word energy is commonly used in our daily life. But in the physics or in the science, it has given a definite and precise meaning for the energy. For example, when a raised hammer hits a nail placed on a piece of wood, it drives the nail into the wood. Also, when the striker hits the stationary carom coin, it sets the carom coin into motion. So in these two examples, the hammer or the striker has a capacity to do work on the other object. Okay. So the hammer, when you strike it, it gives its energy to the nail and it penetrates into the wood. And also, when the striker hits the carom coin, it transfers the energy and it makes the carom coin to move. Okay. So the object which does the work loses energy. At the same time, the object on which the work is done gain energy. Okay. So in precisely the work energy here, it is the capacity or the ability of a body to do work. Okay. So in physics sometimes the energy and work are interchangeably used because they are equivalent concept. So can you say what is the unit of energy? The unit of energy is the joule, because these two, energy and the work done. So because the energy is the capacity to do work, so it is the same concept. They are the same concept, and the same unit of is used for the energy also. Okay. Now we are going to see what are the different types of energy. What are the different types of energy? Energy can exist in many forms, but it can be broadly classified into two categories. One is the kinetic energy, and second one is the potential energy. Let us see what is the kinetic energy. So, a car is moving with a given speed. So when the car hits a wall, the wall breaks. That means the moving object, the moving car can have the capacity to do work. Okay. Similarly, when a boy is running towards you, when the boy hits you, it may make some injury, or it may cause some pain on your body. That means the moving boy can impart energy. It can impart energy to the other person. So every moving object has a capacity to do work. So this type energy possessed by the moving object is called a kinetic energy. Okay. The energy possessed by a body due to its motion is called a kinetic energy. Okay, you can see some of the examples in the figure. Here the meteors, they are coming from the space, outer space to the Earth atmosphere, and when they hit the ground, it makes some collisions with the ground, and it makes some damage. And also when you are walking, and when you are falling, and when you are throwing a ball, and the moving vehicles, all they are in the motion and also have the capacity to do some work. Okay. Suppose if m is the mass of the body and v is its velocity, then the kinetic energy is given by k is equal to half mv square. K is equal to half mv square. Okay. Then move to the second type of energy, that is called the potential energy. So in the figure you can see a boy is try to aim an object with a bow and arrow. Okay, when he stretches the bow with the arrow, so he is putting the arrow in a state of strain or in a state of configuration. Okay, when he releases the arrow, this strain or this energy is transferred to the arrow, and the arrow can move in the forward directions. So here when you try to the string is the boys try to keep the string in a state of strain. Okay, that means it has capability to do work. Okay, similarly when you press a spring, in the second example you can see when you press a spring, and when you release that when you release your hand, the spring will move in the upward directions, and suppose if something is placed on that spring, it can throw that the object at a given place. That means the compressor spring can do work. Okay, and also the third example we can see here is a figure of a peachy dam. So here the water is stored in a very high level, that is in the dam, and when you release the water from a given height, and it moves and it flows down, so it can do work. So it can rotate the turbine of the generator, and it can produce the electricity. Okay, so that means when an object, when you kept it to the given height, has a capacity to do work. Okay, so that means the energy possessed by a body by its position or the state of state. Here, by its position or the configuration is called a potential energy. Is called a potential energy. Okay. Suppose a mass m, suppose an object of mass m is held at a height h above the ground level in the gravitational field of Earth, and suppose if g is the acceleration due to gravity on the surface of the Earth, then the potential energy of the body is given by V is equal to mgh. Okay. Here, the work done on a body is usually, when you do some work, it is usually stored in it as in that body as is potential energy. Here, in the case of the other forces like electric forces or magnetic forces, the potential energy is defined in terms of work done on the object. The work done on a body is usually stored as is the potential energy. For example, if a body is raised against the gravitational force, a certain amount of work is required and it will be stored in the body as its potential energy. Okay. So when the body is released, what happens? The potential energy is converted into kinetic energy. Okay. Now let us see what are the different forms of energy. The different forms of energy. But we know the two basic types of energy and that are sufficient to describe all forms of energy, but it is convenient to refer to a particular combination of kinetic energy and potential energy as its form. Here, some of the major forms of energy include the mechanical energy, heat energy, light energy, sound energy, electrical energy, magnetic energy, chemical energy, and nuclear energy. So let us see some of the different forms of energy. So what is the mechanical energy? What is the mechanical energy? It is the energy of a system due to its motion, position, or configuration. That is, it is the sum of the kinetic energy and potential energy of a system. Okay. What is the heat energy? An object that possesses the heat energy due to the motion of the molecules in it. Due to the motion of molecules in it. Okay. So we know when you take an object, when you take a liquid or in a gas, and even in the solid, molecules are in continuous motion. Okay. So it vibrates, and in the solids it vibrates about its mean position, and in the liquids and gases they are moving. So due to this different types of motion, an object possesses the heat energy. So heat energy released, so this possesses the heat energy. Okay. This energy released, the energy released when we burn wood, coal, oil or gas, that is also called the heat energy. Okay. And also we can see the steam possesses the heat energy, which is capable of doing work. So in the kitchen when we boil the water, and you can see that when the steam is coming, you can see the lid which is kept at the top of the vessel is trying to move. That means the steam is capable of doing work. Okay. So this lifting of weight suggests that the lifting of the lifting of the lid suggests that the heat is a form of energy that is capable of doing work. Okay. In 1765, the James Watt, a young scientist, noticed this phenomena, which led to the invention of steam engine, in which the heat energy was used to do work. Okay. And also we know in thermal power stations, it is the heat energy of burning of coal that is used to generate steam. Okay, the steam in turn runs the turbines of the generator and produces the electric energy. And also the all automobiles use the heat energy by burning petrol, diesel or CNG for doing the work. Or that means for the working of the engine. Okay, and the food which we consume burns slowly in our cells and that produces the heat energy also. Okay. Now the next form of energy is the light energy. Light energy is a form of electromagnetic radiation. Okay. So when an excited electron in an atom or molecule undergoes a transition from higher energy level to the lower energy level, the difference in energy between these two levels is sometimes emitted in the form of light. Okay, that is the basic mechanism in the production of light. Here the light travels as the waves and it is capable of traveling through the vacuum also. We know the plants absorb the light energy and convert into the chemical energy, that means the food, through a process called the photosynthesis. Then next is the sound energy. You know sound. So when you hear my sound, that is, if you are hearing my sound, that means here the energy I produce, it is transmitted in the form of the sound energy, and it is propagating and it is captured by some microphone and is converted into electrical energy, and that is reaches you through the internet or through the mobile data or whatever it is. Then you can reproduce the sound energy. Okay, here the sound energy is produced when an object vibrates. A sound wave, it is the energy travels in the form of the waves. A sound wave needs a medium to travel through the such as the air, water, wood or metal, etc. Okay, when sound waves fall on the ear membrane, they make it vibrate and we can hear the sound. Okay. Then another a form of energy is the electrical energy. The electrical energy is produced by the movement of the electrons, is called the electric energy. Okay. So when electric energy is passed through an electric motor, it sets its axle in a circular motion, and this circular motion is utilized in running of ceiling fans, juicers, grinders, etc. And we are already familiar with. It is also used in heating devices such as the heater, geyser, electric stoves, etc. And also it is used for lightening bulbs. That is used in our incandescent bulb. Okay. Then another form of energy is the magnetic energy. Here the magnetism is described by the magnetic field which are produced either by the magnetic material or by the electric current. Okay, magnetic material means by the permanent magnet. Okay, here the energy stored in the magnetic field is called the magnetic energy. Here a magnet is capable of causing the motion in magnetic substances like the materials like iron, cobalt, nickel are the examples of the magnetic substances. And this magnetic energy is used in the electromagnets and electric motors, electric generators, microphones, television tubes, telephones, etc. Okay, and in all these cases we are utilizing the energy in the form of magnetic energy. Then another form is the chemical energy, and it is defined as the energy stored in the bonds between atoms or molecules in a compound. Okay, when this compound undergoes a chemical reaction, the chemical energy stored in that bonds will be released, most probably in the form of a heat. Okay, so the energy possessed by the fuels like coal, oil, gas, etc. is the chemical energy. And when this chemical energy is burned, their bonds are broken, and the chemical energy is converted into the different other forms of energy, maybe most probably in the form of heat. Okay, here the chemical energy of diesel, petrol, CNG is capable of moving the vehicles, that we know. Okay, and also the food that we consume possesses the chemical energy which is utilized by our body to do work. This another form of the energy is the nuclear energy. Here, the binding energy of the nucleons. Here, nucleons means the neutrons and protons which are residing in the nucleus. So we have to, in order to keep these protons are the positively charged particles. So there is a strong repulsive electrostatic force. So in order to overcome this force and to bind the nucleons in the nucleus, there is a energy. That energy is called nuclear energy. The nucleus in an atom has an enormous amount of energy which hold the proton and the neutrons together. When a heavy nucleus split into lighter nuclei or two or more lighter nuclei, we can also in the reverse process. In the reverse process also, when the light nuclei combine to form a larger one, there is a large amount of energy is released. A large amount of energy is released. Okay, and this energy is this is the origin of the nuclear energy. Now we are using the nuclear power stations. Okay, and we are in India also. In India there is also a need for the energy, and the nuclear power stations are the most reliable sources of energy. Okay, so that means the nuclear fission or fusion releases the nuclear energy in the form of heat and light energy. Okay, as I already said, in the nuclear power stations, here the nuclear energy is used to generate electric energy. And also in the case of atom bomb or hydrogen bomb, here the nuclear energy is used for the destructive purposes, that already we know. Okay. Then another type of form of energy, that is the solar energy. Okay, solar energy is the radiant light and heat from the sun. Here how the solar energy is created? It is created by the nuclear fusion that takes place in the sun. Okay, so it is the primary source of all kinds of energy on the earth. Okay, so we receive the animals, plants, all these, everything in the earth receives the energy from the sun. Okay, sun is the prime source of energy. Here the solar energy provides wind energy, tidal energy, and energy of sea waves also. Okay, and it causes the evaporation of the water, which in turn leads to the water cycle. Okay, we are already studying in the lower classes, and the phenomenon of the photosynthesis is not possible without solar energy. So that is the solar energy. That is the main. It is the main reason for the existence of life on the surface of Earth. So without solar energy, we cannot survive. So it is necessary for life on the Earth, and it can be harvested for the human use in many ways. For example, the solar cells. So the solar cells absorb the sunlight and convert the solar energy into the electrical energy. Okay, and also the solar cooker, solar water heater, etc. They are also utilizing the heat energy present in the solar radiations.